Hello viewers, in this video we'll look at two things. So number one, we'll look at evaluation of combinations. Then number two, we'll look at expressing combinations in the form n combine r, where n is always greater than or equal to the value of r. That's what we'll look at today. So we have our first question, and the question says, find the number of the following combinations. Find the number of the following combinations. So in the question says that it means you are evaluating these combinations. So we have to evaluate these combinations that we have. So the general formula that we use is n combine r, okay, which is equal to n factorial over n minus r, then factorial, then r factorial. That's the general formula that we use. So that means for part 1 we are given 5 combine 3. So for us to evaluate this, we use the same general formula. So here on this formula, n is 5 and the value of r is 3. So we have now 5 factorial over that is now 5 minus 3 factorial 3 factorial. So now we need to simplify this. So this will give us 5 factorial over, here we subtract, we say 5 minus 3, we get a 2 factorial, then here 3 factorial. Then after this now, we look at the bigger number with a factorial, which is 5 factorial. Then we'll reduce it up to 3 factorial, the number close to it, which is a 3 factorial. So we say 5 times 4 times 3. Then we are ending at 3 factorial. Remember, so we end at 3 factorial. Then we're going to say over, that is 2 factorial, 3 factorial. So now we can cancel 3 factorial and 3 factorial, so that now we remain with 5 times 4. Then we say over 2 factorial, it is 2 times 1. So also here, remember, for this type of mathematics, we don't use a calculator, so we just need to simplify. So 2 into 2, that's a 1. Then 2 into 4, that's a 2. So now we have 5 times 2, which gives a 10. So basically here it means that 5 combine 3, we get an answer which is a 10. Then now for part 2, we have that is 10 combine 2. So like I said, we use the same formula. So it will be n will be 10 factorial over, then we have 10 minus 2 here. Then we say factorial, then 2 factorial. So now this, let's see what it will give us. So now on top we have on our numerator we still have a 10 factorial. Then for the denominator we subtract. So we say 10 minus 2, we get 8 factorial, then 2 factorial here. So as we reach here now, we need to reduce 10 factorial up to 8 factorial. So it will be 10 times 9 times 80 factorial. Then now we say over, that is 8 factorial 2 factorial. So here 8 factorial and 8 factorial cancels. Then we remain with 10 times 9 for our numerator. Then for the denominator, we have a 2 factorial. So for this 2 factorial, we can evaluate it by saying it is 2 times 1. Okay. Then after that now, we say 2 into 2, that's a 1. Then 2 into 10, we get a 5. So now 9 times 5, we get a 45. So this one becomes the answer for part 2. So now we move to part 3. So for part 3, we have 25 combine 1. So I have to evaluate this. So what we do first, we write the general formula, which is n combine r. That's the general formula we use, which is equal to n factorial over, that is n minus r, then here factorial r factorial. Okay, so now this means for 25 combine 1. Okay, here the answer will be n will be 25. So we have 25 factorial, then we say over what is n now? 25 minus 1. Okay, then factorial, then r is 1, so we say 1 factorial here. So now let's evaluate this. So for the numerator we have 25 factorial, then for the denominator we say 25 minus 1, which gives us a 24, then factorial, then 1 factorial, of course. All right, so let's maintain. So again 1 factorial here. So now we need to evaluate this. So what we'll do is we'll reduce 25 factorial up to 24 factorial. So it will be 25 times 24, that is factorial. Then we divide by 24 factorial and 1 factorial. So here 24 factorial and 24 factorial cancels. We have 25 over, then 1 factorial, that's a property which is a 1. Okay, so 25 over 1, we get a 25 as the answer. Then now moving to part 4, we have to evaluate, that is 12 combine 12. So for this one, we use the same general formula where we say n combine r should be equal to n factorial over n minus r. Okay, factorial r factorial. So this means for 12 combine 12 here, the answer would be n is 12. Okay, then factorial over n, that's a 12, minus r is also a 12. Okay, then factorial, then 12 what factorial. That's what we have. So now let's evaluate this. So we have 12 factorial for our numerator. Then for the denominator, 12 minus 12, it gives a 0. Okay, it gives a 0. So here we say 0 factorial, then now 12 what factorial. So now this gives 12 factorial and 12 factorial cancels. So on top we have 1 for the numerator over 0 factorial, that's a property which is a 1. So 1 divided by 1, we get a 1, the answer. Now we move to the second thing where we have to express each of the following in the form n combine r, where n and r are positive integers with n greater than or equal to r. So for this, we answer it as if we are evaluating like what we are doing for our question number 1. So the general formula that we use is n, okay, combine r, which should give us, that is n factorial over n minus r, then factorial r factorial. That's what we do. So now we start substituting. We start with 9 combine 3, so it becomes 9 factorial over now 9 minus 3. Okay, then factorial 3 factorial plus the 9 combine 4, which will be 9 factorial over 9 minus 4 here, then factorial 4 factorial. It will be that. Now after that, we simplify it further. So we have 9 factorial over, so now 9 minus a 3, it will give us a 6. So it will be 6 factorial 3 factorial. Then e plus 9 factorial over the 9 minus 4, it gives a 3 factorial 4 factorial. That's what it will give us. So now once we reach here, we don't evaluate it, no. Once you reach here, what you always do is you find the common denominator. So as you're getting the common denominator, you always check what you have. So for our denominator, the first one, we can see that here is 6. So this 6 is greater than 3. So even here at the far end, it should be the same. Okay, so we should have 4 factorial times 3 factorial. So we need to switch here. So we'll switch these. So we'll say we have 9 factorial over 6 factorial 3 factorial plus, so 9 factorial over, so what I was saying is we need to switch this so that the first number should be greater than the second number, so it becomes that. Okay, so that now after this, now let's see what would be, we need to get the common denominator. Okay, we need to get the common denominator, and as you are getting the common denominator, you get the bigger numbers. So here we are trying, so we say the first numbers, we have 6 factorial and 4 factorial. Okay, so now between these numbers, the bigger number is 6 factorial, so therefore here 6 factorial becomes the common denominator. Then for these our second numbers, we have 3 factorial. Okay, so this is what we have now. Okay, so this is what we have. So here the secret is as you are getting the common denominator, when you add, because we have 6 factorial and 3 factorial, so just try to just ignore the factorial and say 6 plus 3, it will give us 9. And you can see that on our numerator we have 9 factorial, so what we should get, it should be a 10. Okay, I hope you're getting what I'm saying. So we should get a 10. So since when we say 6 plus 3, we're getting a 9 and not a 10, meaning that here there we're not supposed to swap. So meaning we go back here, we are not supposed to swap, so we take it the way it is, because what we want is when you get the two common denominators, you should get what? 10 factorial. So we'll say here again we come the common denominator. Now what we have to get now are bigger numbers. So now we say for the first two numbers we have 6 factorial and 3 factorial. So here the bigger number is 6 factorial. So 6 factorial becomes the common denominator. Then between 3 and 4, the last numbers 4 factorial becomes the common denominator here. Okay, so now you can see that when you say 6 plus 4, it will give us 10, which is after 9 factorial. So that's the correct way to do it. So now we need to get the common denominator. So for the common denominator, now we say this our denominator that we have, which is 6 factorial 4 factorial, we say we divide by this first part, where here where we have 6 factorial 3 factorial. So we say 6 factorial 3 factorial. So here we can see that 6 factorial cancels, we remain with 4 factorial, that is over 3 factorial. So now we need to evaluate this. So we reduce a 4 up to 3, so it will be 4 times 3 factorial over 3 factorial. So 3 factorial and 3 factorial cancels, we have a 4. So we have a 4 open 9 factorial, then plus we do the same thing. So we say 6 factorial 4 factorial, now divide by what we have just here, which is 3 factorial 4 factorial. So here we can see that 4 factorial and 4 factorial cancels. Now we remain with 6 factorial over what? Over 3 factorial. So for this, we reduce 6 up to 3, so it will be 6 times, that is we reduce 6, so you say 6 times oh, I'm so sorry. So here we've made an error when we were subtracting. Let me just here, okay, just for this part there is just an error. So here it will be 9 factorial over, okay, So now here it will be 9 minus 4. It's not what we wrote. 9 minus 4, that's a 5. Okay, factorial, then 4 factorial. So this is what we have. So now let's also confirm for the common denominator. Okay, so if we are to confirm for our common denominator here, we can see that here when we look at the first numbers, we have 6 factorial and 5 factorial. Still the bigger number is 6 factorial. Okay, for the second numbers, we have 3 factorial and 4 factorial. So 4 factorial becomes the common denominator. So now we do the same. Now we say 6 factorial, 4 factorial. We divide this by 6 factorial, 3 factorial, which is that. Okay, so now let's evaluate. Now 6 factorial and 6 factorial cancels. Then we remain with a 4 factorial over 3 factorial. So here now what we do is we'll reduce a 4 up to 3 factorial. So you say 4 times, that is 3 factorial over 3 factorial. So here 3 factorial cancels. We remain with a 4. So now we have 4 times what? 9 factorial plus. Here we do the same. It will be 6 factorial, 4 factorial over 5 factorial, 4 factorial. So 4 factorial cancels. Now we have 6. We reduce it up to 5. So 6 times 5 factorial over 5 factorial. This cancels. So now we have 6 open, then 9 factorial. So now let's simplify this further. So now on top we can see that on our numerator 9 factorial is common. So therefore we'll factor out 9 factorial, which is common. So now we'll remain with what? 4 plus what? 6 when we factor out 9 factorial. Then we're going to say over, that is now 6 factorial, 4 factorial. So now we have 9 factorial, then 4 plus 6, we get a 10. Okay, so here we are multiplying, then over 6 factorial, 4 factorial. So now we can see that 10 is bigger than 9 when we ignore the factorial. So what we'll do is we'll start with a 10. So we say times what? 9 factorial over then 6 factorial, 4 factorial. So now here we can combine, because when we have 10 times that is 9 factorial, you know this can be written as 10 times 9 times 8 times 7 times 6 up to 1. So this can be combined and be written as what? 10 factorial over 6 factorial 4 factorial. So now here we come and conclude to say therefore the answer is 10 combine 6 without factorials, or 10 combine what? 4. So that's how we evaluate this one. I mean, that's how we express it in the form N combine R. That's how we express it in that form. Now we can try out this our second one. So we use the same general formula. We say N combine R should be equal to, that is N factorial. Okay, then we say over, that is N minus R, that is factorial R factorial. So here we start with 20 combine 9. So which gives here it will be 20, okay, factorial over, now it will be 20 minus 9, then here factorial 9 factorial. Then I'm going to say plus, here it will be 20, okay, factorial over 20 minus 8, then here we say factorial 8 factorial. So let's simplify it further. So we have now 20 factorial over 20 minus 9, it gives 20 minus 9, it gives 11 factorial 9 factorial here. Then we say plus. So now we have 20 factorial over 20 minus 8, it gives a 12 factorial, then 80 factorial. So that's what we have. So now after reaching here now, that's where we get the common denominator. So like I said, you make sure you check as you are getting the common denominator. Okay, so what you always check for is um, if you try to get the common denominator here, when you look at the first numbers, we have 11 factorial and 12 factorial. Okay, so here between 11 and 12, we can see that 12 factorial will be greater. Okay, also between 9 and 8, we can see that 9 factorial will be greater there. So the secret is when you say 12 plus 9, here we get a 21. So this 21, look, on top, on our numerator, we have 20 factorial, meaning that for when we add the denominators, when you just ignore the factorial, you should get 21, because after 20 you have 21. That's what you should be getting, because if you are getting 20, it won't work out. So here, that's the correct common denominator now. So we move and say now the same denominator, 12 factorial, 9 factorial, we divide it by this. Okay, so we have 11 factorial here, 9 factorial. So 9 factorial, 9 factorial cancels. Then now we have that is now 12 factorial over 11. So now we need to reduce this, so it will be 12 times up to 11 factorial, then over what, 11 factorial. This cancels, we have a 12. So now I have 12 times what, 20 here. Okay, so this 20, it is a factorial. Okay, so 12 times what, 20 factorial. Then we say plus again, we say 12 factorial, 9 factorial, then that is over 12 factorial, 8 factorial, this one here. Okay, so here 12 factorial and 12 factorial cancels. We have 9 factorial over 80 factorial. So we need to evaluate this by reducing 9 up to 8. So it will be 9 times what, 80, okay, factorial, then over 8 factorial. 8 factorial, 8 factorial cancels. We have 9. Here we have 20 factorial. So this is what we have. This is what we have. So once we reach here, now we're going to say on top, on our numerator, 20 factorial is common. So since 20 factorial is common, we factor it out. So we factor out a 20 factorial. Then we remain with now 12 plus what, 9. Then over, that is 12 factorial, 9 factorial. So now we have 20 factorial times 12 plus 9, it will give us a 21. Then over 12 factorial, 9 factorial. So now what we're going to say now is we'll start with 21, then times what, 20 factorial, so that we combine these. Okay, so we say over now that is 12 factorial, 9 factorial. So now here 21 times 21 times 20 factorial. 20 factorial can be written as 20 times 19, you know, up to 1. So that is 21 factorial. So it can just be written as 21, that is factorial, over 12 factorial, 9 factorial. So now we can even conclude to say the answer becomes 21 without a factorial. Combine the first denominator, or 21 combine the second denominator. So that becomes the answer. Then moving to the third one, where we have three combinations, we have to express them still in the form n combine r. So by now you know to say the general formula that we are using is n combine r, which is equal to n factorial over n minus r factorial r factorial. So we'll start with 7 combine 3. So it will be 7 factorial over now 7 minus 3 factorial, 3 factorial. Then plus that is 8 factorial over, it becomes 8 minus 5, then factorial 5 factorial here. Then we're going to say plus the other one, which is 7, okay, factorial over 7 minus 3, okay, factorial 3 factorial. So let's simplify it further. So we have 7 factorial over, now 7 minus 3, that's a 4, so factorial 3, okay, factorial. Then we're going to say plus, here we have 8 factorial over 8 minus 5, it gives a 3, so 3 factorial, then 5 factorial. Then plus, here we get 7 factorial over, so now 7 minus 3, we get a 4 factorial, okay, 3 factorial here. That's what we have. So now once we reach here, we find the common denominator, like I said. So here, as you are getting the common denominator, it's the same concept. So on top, since we have 3, okay, numbers, that is 7 factorial, 8 factorial, and 7 factorial. So these are our numerators. So what you are looking for is, you look at the bigger number, okay, which is 8 factorial. So meaning that when we get our common denominators, we should get a 9 when you add them, those two common denominators. So here, if you try to get it the way it is without changing anything, let's see. For the first numbers, we have 4, 3, and 4. So this means the common denominator will be a 4. Okay, we move to the second numbers. We have 3, 5, 3. So we get what? A 5 factorial. When you look at this, when you say 4 plus 5, it should give us a 9. So this is correct now. We don't need to swap anything. What we do, just go ahead and say, now 4 factorial, 5 factorial, we divide it by here. Okay, the first denominators. Okay, that is 4 factorial, 3 factorial. So 4 factorial and 4 factorial cancels. Now we remain with a 5 factorial over, okay, 3 factorial. So now what we do is we say, okay, here we reduce 5, okay, up to 3. So it will be 5 times 4 times what? 3 factorial over 3 factorial. So 3 factorial and 3 factorial cancels. So we have a 20, okay. So now we have 20 now times 7 what? Factorial plus. We do the same for the second part. So it will be 4 factorial, 5 factorial now over this our second denominator, which is 3 factorial, 5 factorial. So 5 factorial and 5 factorial cancels. So our 4. Now we can reduce it up to 3. So up to 3 factorial over the 3 factorial. This and that cancels. We have a 4. So now it will be 4 open. Now 80 factorial plus. Okay. So we do the same for the last part. So it will be 4 factorial, 5 factorial over 4 factorial, 3 factorial. So here 4 factorial and 4 factorial cancels. We have 5 factorial over 3 factorial. So we can just reduce 5 up to 3. So 5 times 4 times 3 factorial over 3 factorial. This and that cancels. We have a 20 now times 7 what? Factorial. So now we need to simplify this now further. So what we'll do is we'll get the common denominator on top. Okay, so before we get the common denominator, we can collect our like terms. So what we'll say is we have 7 factorial there. So we'll say we have 20, okay, then 7 factorial, okay, plus here 20, here we have 7 factorial, then plus that is 4, then here 80 factorial. Now we're going to say over 4 factorial, 5 factorial. That's what we're going to say here. Okay, so this means now once we reach here now, For the numerators, we have 7 factorial common between these two numbers. So we factor out 7 factorial because it is common. So once we factor out 7 factorial, we remain with a 20. Okay, plus what? 20. Then now plus here, that is 4 open 80 factorial. So now we're going to say over 4 factorial 5 factorial. Now once we reach here, what we do is now we add. So here we have 7 factorial, 20 plus 20, that's a 40. Okay, then now plus here 4 open 80 factorial, then over 4 factorial 5 factorial. So now we have 7 factorial. So what to do, say open 40, will split it. Okay, because 7 factorial is less than 8 factorial when you look at these numbers with factorials. So what to do is you just divide. You say 80, you say 40 divided by 80. Okay, so when you say 40 divided by 8, it gives a 5. So 40 divided by 8, it will give us how much? Let's see. So now we are dividing 40 divided by 8. Okay, let's see. So 2 into 40, 20, 2 into that 2 into 8, 4. Okay, so 5. Yeah, so this means when you say 80 times what? 5, we still get a 40. We are just introducing 80 factorial that we have the bigger factorial on this side. So now we say plus now 4 open 80 factorial. Then we're going to say over 4 factorial 5 factorial. Okay, so now let's simplify it further now. So now what we'll have is so let me create some space just here. Okay, yeah, so now what we're going to have is now we have, I'll start with 8 here. So I'll say 8 times what? 7 factorial, then we have a 5. Then we're going to say plus 4 open 80 factorial, because we want to introduce 8 factorial. Then over, that is 4 factorial 5 factorial. So here 8 times 7, these can be combined and be written as 8 factorial now times 5. Okay, plus that is now I'll say 8 factorial times a 4. So now we say over 4 factorial 5 factorial. So now once we reach here, or on the numerator, we can factor out 8 factorial because it is common. So now we have 5 plus a 4. Then over 4 factorial 5 factorial. So now we have 8 factorial times 5 plus 4, that's a 9. Okay, over 4 factorial 5 factorial. Okay, that's what we do. So now like I said, here we can combine 8 times 9, and we can say 9 times 8 first factorial. Okay, over, that is now 4 factorial 5 factorial. So here 9 times 8 can be written as 9 factorial over 4 factorial 5 factorial. All right, so now the answer now becomes 9. Okay, combine 4. Okay, and also a 9 combine what? 5. So that becomes the answer. Then we have this part 4. Let's try it out as well. So for this one, the same, it will be now 10 factorial over 10, okay, minus, that is 6, okay, factorial 6 factorial plus 11 factorial over, it will be 11 minus 6, okay, factorial 6 factorial. Then we say plus now 10, okay, factorial over 10 minus 3 factorial 3 factorial. That's what we'll do. So now after that, what we do now is we say 10 factorial over 10 minus 6, it gives a 4. Now factorial 6 factorial. So plus here we say that will be 11, okay, factorial over 11 minus 6, that's a 5. So factorial 6 factorial. Now plus here 10 factorial over 10 minus 3, that's a 7. So factorial 3 factorial. So that's what we have. So once we reach here, we find the common denominator using the same concept. So it will be over, okay? So we'll have over. So now we start looking at the first numbers 4, 5, 7. So the bigger number 7 factorial. Then for the last numbers we have 6, 5, 6, 6 and 3. So 6 becomes the common denominator. So since the bigger number on our numerator is 11, so you should get 12 when you say 7 plus 6. So when you say 7 plus 6, when we add these numbers, they're giving us a 13, which is not what 12. So meaning that somewhere we need to switch. Or okay, fine. So let's just switch so that I don't confuse anyone. So now since we have 4 factorial here, which is smaller than 6 and 5 is smaller than 6, less than to say. So meaning that to switch here, we'll say 3 factorial will start, then 7 factorial will end. So we have 10 factorial over now 4 factorial 6 factorial plus 11 factorial over 5 factorial 6 factorial. Okay, then we say okay plus 10 factorial over so 3 factorial 7 factorial. So now that's when we can get the common denominator, and here the common denominator will be 4, 5, 3. We have a 5, the common denominator. Then 6, 6, 7. So we have 7 factorial. So you see, when you say 5 plus 7, we'll get a 12, which is after 11. So this is okay now. So after this now, we say 5 factorial, 7 factorial over the first part here. Okay. So that is now we get so that's 4 factorial 6 factorial. So what we do is here we can reduce 5 up to 4 first. So to be 5 okay times 4 factorial okay over 4 factorial. Again 7 will reduce it up to 6 factorial. So to be 7 times what 6 factorial, then here 6 factorial. So now we can see 4 factorial cancels, 6 factorial cancels. We have 5 times 7, which gives 35. So here we have 35, open 10 factorial plus. We do the same for the next one. We do the same. So it will be 5 factorial, 7 factorial over 5 factorial, 6 factorial. So you can see that 5 factorial and 5 factorial here can cancel. Then we reduce 7 up to 6 factorial. Okay, like this. This we have a 7. So now it will be 7 times 11 factorial plus. Then for the last part, we do the same. So it will be 5 okay factorial, then 7 factorial over 3 factorial 7 factorial. So now here we can see 7 factorial and 7 factorial cancels. So now we have 5 factorial over 3 factorial. So we can reduce 5 up to 3. So 5 times 4, then times 3 okay factorial over 3 factorial. This and that cancels. We have a 20. So now it will be 20 times what 10 factorial. So now once we reach here now, the next thing is now to collect the like terms. So on top of 10 factorial, even here 10 factorial. So we'll collect the like terms. So now we have 35 here, 10 factorial. Now okay plus that is 20 here, 10 factorial plus that is 7, now 11 factorial. So we say over, that is 5 factorial 7 what factorial. That's what you say here. So after this now, the next thing that we're going to say is, um, for the first two numbers here on top, 10 factorial is common, so we factor out 10 factorial. Now we have 35 plus what 20. Now plus, that is 7 open 11 factorial over, that is 5 factorial 7 factorial. Okay, so now what to do is, next is, we have now 10 factorial. Okay, 35 plus 20, that's a 55, plus this is 7 11 factorial, then we say over, that is 5 factorial 7 factorial. So what to do is, we are looking at a bigger number with a factorial, which is 11. So we're going to say 55 divided by 11, so that we introduce 11. So it will be now 10. 55 divided by 11 is a 5, so it will be 11 times 5. Now plus 7 here, 11 factorial over, that is 5 factorial 7 factorial. So we can go further. So now here what we have is, so remember this 10, it is a factorial here. So I'll start with 11 times this is 10 factorial, remember, then times a 5. Now plus, this is 7 open, this is 11 factorial, then we're going to say over 5 factorial 7 factorial. So now what to do next is, 11 times 10, these can be combined and be written as 11 factorial, now times a 5, plus here I'll start with 11 factorial times 7 over, that is 5 factorial 7 factorial. So now 11 factorial is common, so now we have 5 plus what a 7 over 5 factorial 7 factorial. So of 11 open, 5 plus 7, that's a 12 over, here is 11 factorial, so over 5 factorial 7 factorial. So let's go ahead and say now, I'll start with 12 times what 11 factorial over 5 factorial 7 factorial. So 12 times 11 can be combined and be written as just 12 factorial over, this is 5 factorial 7 factorial. So now here the answer becomes now 12 combine 5, okay, or 12 combine what 7. So that becomes the answer. And we've come to the end of the session.